Hello students, welcome. Previously, lesson 22, form 4 topic 4, we are dealing with the fourth aim of calculating Faraday's first law of electrolysis, which was determining the relative atomic mass of element. So today, lesson 23, we want to proceed to the fifth aim, that's determining the charge on a metal, or in other words, the number of Faradays, which we can write in a small letter. So the formula used when we are looking for the charge on a metal or the number of Faradays, which we can write any small letter, will be equal to Q multiplied by Ram divided by M times F, where Q is the quantity of electricity passed, and we can get Q is equal to IT, where I is current, which is measured in amperes, and T is time, which must be in seconds. Then we are having M is mass in grams deposited, N is the number of electrons gained or lost. In other words, the number of Faradays or the charge on a metal, or the value on the charge of a metal. Then F is Faraday, and Faraday is equal to 96,500 coulombs. Then Rm is equal to relative atomic mass of element. Then we go to examples. Example number 1. We are told in an experiment to electrolyze copper 2 sulfate solution using copper electrodes. We are told 0.2 amperes were passed through the solution for 1930 seconds. The mass of copper cathode increased from 6.35 gram to 6.478 gram. Find the charge on a copper ion. Then we are given in bracket the Rm of copper is 64 and 1 Faraday is equal to 96,500 coulombs. We got the solution. Let's start first of all by getting the mass deposited. Here we are going to take 6.478 gram, then we subtract 6.35 gram. Here we are going to get 0.128 gram. So that's the mass of the copper deposited on that copper cathode. So next we are going to go to the formula. Number of Faradays or the charge on a metal will be equal to Q, that's the quantity of electricity, multiplied by Rm divided by mass multiplied by F. So N will be equal to, so the quantity of electricity, we said it is obtained by using the formula IT, where I is current measured in amperes, that's 0.2, multiplied by time, which is measured in seconds. So we are given 1930 seconds multiplied by Rm. The Rm of copper is 64 divided by, then M is the mass deposited, that's what we have gotten, 0.128, multiplied by F, that's Faraday, which is equal to 96,500 coulombs. So when we put all this in the calculator, the number of Faraday that we are going to get here will be 2. So the charge of the copper will be balance 2. Example number 2, we are told a nitrate of a metal M was electrolyzed. 0.117 gram of metal was deposited when a current of 0.4 amperes followed for 16 minutes. We are asked to determine the formula of the sulfate 6 salt of the metal. In bracket, we are given Faraday constant, which is equal to 96,500 coulombs, and we are told Ram of X is equal to 59.0. So solution. So the formula for calculating number of Faradays, we say it is equal to Q multiplied by Rm divided by M times F. So Q is quantity of electricity passed, and the formula for using quantity of electricity is IT, where I is current measured in amperes, so 0.4 multiplied by time. The time we have here is 60 minutes, but we have to convert it into seconds by multiplying 60 times Rm. The Rm of X is 59 divided by M. M is mass deposited. The mass here is 0.117 multiplied by F. F is Faraday, which is equal to 96,500 coulombs. When we put all this in the calculator, we are going to get 2. So the charge of metal is balance 2. Then if the charge is plus 2, that means the valence of M is also 2. Therefore, the formula between M and sulfate 6 will look like this. The valence of M is 2, the valence of sulfate 6 is 2. We will interchange the valence. Then if there is a common factor, we divide by 2, 1 by 2, 1. So the formula that we are going to get there will be M SO4. So that's what we have here, M SO4. Example number 3, we are told an element B has a relative atomic mass 88. That is the RAM. When a current of 0.5 amperes was passed through fused chloride of B for 32 minutes and 10 seconds, 0.44 gram of B was deposited at the cathode. We are told determine the charge on an ion of B. In bracket, we are given Faraday's constant, which is equal to 96,500 coulombs. Solution. The formula for calculating number of Faradays is just equal to Q times Rm divided by M times F. So where Q is the quantity of electricity passed, and it is obtained by using the formula IT, where I is current in amperes, so that's 0.5 multiplied by T, that's time, which must be in seconds. So we are supposed to take 32 minutes multiplied by 60 to convert it to seconds, and we are going to add 10 seconds there, multiplied by Rm. The Rm of B is given 88, divided by the mass deposited is 0.44 gram, then multiplied by F, which is the Faraday constant, that's 96,500 coulombs. When we put all this in the calculator, we're going to get 2. That means the charge of B, or the oxidation number of B, will be plus 2. Example number 4. We are told electrolysis of an aqueous solution of salt of metal M resulted in the deposition of 1.07 gram of the metal upon passage of a current of 1.32 amperes for 75 minutes. Whereas to calculate the charge on the metal ion. In bracket, we are given Faraday constant, which is equal to 96,500 coulombs, and we are told Rm of M is equal to 52.0. So we got solutions, and that's the number of Faradays will be equal to Q multiplied by Rm divided by M times F. So this will be equal to Q is the quantity of electricity passed, and we are going to use the formula IT, where I is current in amperes, that's 1.32 multiplied by time, that's 75 minutes, but time must be in seconds. We have to multiply by 60 to convert it to seconds. Then we multiply by 52, which is the Rm of metal M. Then we divide by mass, that's M. Here we are given the mass 1.07 multiplied by F, that's Faraday, which is given 96,500 coulombs. When we put all this in the calculator, we are going to get 2.99. We have to put it in whole number, that's we are going to get 3F, that means 3 Faradays, and the charge of metal will be plus 3, or the oxidation number will be plus 3. Lastly, learners, we are going to go to the extended questions. We have 2 extended questions.